Okay, the last lesson was about how to form a causal hypothesis, and we looked at three methods of forming a causal hypothesis. This next section of the book talks about three methods of confirming a causal hypothesis. That is, in the last lesson, our question was, usually we make claims about cause and effect because we see two things going together. One thing happens, another thing happens, and so we assume because the two things go together that one causes the other. Well, sometimes we do good at that and sometimes we do bad at that, and so we want a way of forming recognizing or forming causal hypotheses that's good, that's reasonable, that leads to truth more often than not. So the last lesson was about three different methods that we can form a causal hypothesis, or what we call a causal guess, right? So we had paired unusual events. Something unique happens and something else unique happens. So we're going to, okay, then they go together, so then there's a causal relationship. You can have common variables, so there's a number of instances of something, and so you look for something else that is also in every instance of that, so that it's more than one and there two things agree. And then there's the covariation principle, where you have something that varies and then you look for something else that varies with it, that goes up and down with it. Okay? Now we're on to, in this lesson, confirming causal hypotheses. That is, once we've got our good guess, our hypothesis, and we've generated a good one, now how do we confirm it? Now, there are, and this will take you back to your psychology courses and your biology courses and all your science courses, there are three different ways that we generally will confirm a causal hypothesis. So our task here is, when we confirm a causal hypothesis, what we're trying to do is show that if not for this one thing, that is the suspected cause, the effect that we're interested in wouldn't have happened. Okay? So that's really what we're looking for when we're confirming a causal hypothesis. If this wasn't there, then that wouldn't have happened. And we refer to that in Latin as the conditio sine qua non. Sine qua non. Conditio, you can see condition really is the word. Sine qua non is without which none. So it's the condition without which it would not have happened. All right? Okay, well, what's the first method? I'm going to keep this lesson short if I can. What's the first method for confirming my hypothesis? So I've got my hypothesis, now I want to confirm it. Well, the first one, and the most obvious one, will be a randomized controlled experiment. In a randomized controlled experiment, we're going to take two groups of subjects and we're going to randomly, and this is an important word, randomly assign the subjects to either an experimental group or a control group, and they should be pretty much identical. And then to the experimental group, I'm going to apply the certain cause and then look for the effect. And the control group gets nothing, or maybe a placebo, right? We've all heard about these sorts of experiments. So let's look at an example here, right? So in an experiment, you're going to take 50 willing volunteers who are infected with a cold virus, which you better pay me good money for that because I hate getting sick, and then randomly divide those people who have the cold into two groups. The subjects in one group will be given Zicam, and the subjects in the other group will not. They'll be given a placebo, let's say. 2 weeks later, the number of people with colds in both groups will be compared, right? And what we're looking for, since the one group got Zicam and the other didn't, we're looking for how the cold went. We're testing the hypothesis that Zicam makes your cold go away, right? So we have this experiment. We break them up into two groups. Everybody's infected with a cold, with the same cold, by the way. And then we give the experimental group Zicam. We don't give the control group anything. We give them a placebo, basically. And then there we check out to see what happened. 18 of the subjects, let's say, who had not been treated had colds, and only 10 of the subjects who had been treated with Zicam had colds. Then it looks like Zicam causes your cold to go away more quickly, right? Then there's a causal relationship. Why? Because we notice a difference in the number of people who have colds and don't have colds between the experimental and the control group. So this is the conclusion we would reach then, is that Zicam probably reduced the frequency of colds in the experimental group. Now, with this, these randomized controlled experiments, there's actually a lot of science and statistics that goes into this. So in your textbook, you'll have a table, and that table will be on, I think it's table 11.2, and in the 11E edition of your book. And let me see if I can find the page for that real quick so that you know. I see it on page 366, and it is table 11.2. Sometimes, well, very often, when you have your two groups randomized into a control group and an experimental group, and you administer something like Zicam, there will, of course, always be random variations between your control and your experimental group, even if you do nothing on either. So we have to account for the fact that some of the difference between the two groups could be the result of chance. Well, for that, we have then table 11.1 shows us a table that allows statisticians to know for sure, or at least with a high degree of confidence, I should say, whether the results that we get, the difference that we see between our experimental and our control group, is what we refer to as statistically significant. That is, significant or large enough to know that there's a cause and effect relationship there. So if you look in that chart, what you'll see is on the left-hand column, they'll list the number in the experimental group. And then to the right, you'll see the degree of difference that you need between the two groups for your findings to be statistically significant. And what you'll notice is that the larger your experimental group, the lower the percentage needs to be statistically significant. So if I sampled 10 people, well, we did 50, right? So we did 50 people in our Zicam experiment, and if you look across from 50 on that book, the statistically significant difference between the two must be 19%. So if there's a 22% difference between my control and my experimental groups in the percentage of people retaining or with or without colds, then that difference is statistically significant, and at that point I can say with some degree of confidence that Zicam plays a role in that cold going away, that it causes the cold to go away more quickly. If, however, I have 50 people and the range of difference between them is, say, only 10%, well, a 10% range at only 50 people is within statistical norms. Remember, each of our experiments will vary, right? Remember back to when we had the lesson on reaching in the barrel and pulling out marbles, right? We're going to get variation every time that we do that. Well, it's the same thing with a scientific experiment. Groups will have random variations between them that are not statistically significant in order to establish that our effect, or that our cause really is playing a role here. We need the variation to exceed what would be random for it. Now, random is determined by the number of candidates that you have in that left column. So if we sampled 1,500 people and we got a deviation between my control and my experimental group of 20%, that is way outside of what we think is statistically the margin of error here, statistically significant. by 17, by 3% is what we would expect. And if we get 20, then we are well within the range of saying, yes, there's a causal relationship here. But that's how to sort of look at, and I want you to be familiar with, you will need to be familiar with for your exam, how to read and how to go through that table 11.2. Okay? So that's off of a randomized controlled experiment. Remember, randomized control. So we randomly assign people to different groups, and we are controlling who gets and who doesn't get the cause to measure for the effect. And we are looking for something that is statistically significant as reflected in the graph on 11.2. Okay? All right, the next one is called a prospective observational study. This is probably one that's done more often in informal studies. In this one, we are not, we don't control as much. Okay? So in this one, what you'll have is two groups. In one, you'll have the suspected causal agent, and in the other, you'll have it where that causal agent is not there. But I'm not controlling the groups, and that's the big difference here. So I might be doing a survey where I'll say, I want 100 people who have a bachelor's degree, and I want 100 people who have a master's degree, and I want to compare to see if your degree has some sort of impact on your income. Then what I'm going to do is I'm going to divide the group into two different groups, right? Those with the suspected cause with a bachelor's degree and those with an AA degree or AS degree, a 2-year degree. And then I'm going to look at their income, okay? So this is a study of two groups, one in which the suspected causal agent is universally present and the other of which it is universally absent. A significant difference in the frequency of the suspected effect in the comparison groups is evidence of a causal link between it. Okay, so let's do the example, right, to clear this up, because right now I'm sure that's clear as mud. Let's do the example. Let's say I want to know whether whether students' grades are affected by how much they party. So I want to know if party goers have lower GPAs than non-party goers. And what I'm going to do is I'm going to get a group of 100 students who would identify themselves as attending parties on most weekends. And then I'm going to get another group of 100 people who say that they rarely or never attend weekend parties. And then what I'm going to do is I'm going to map out their GPAs. I'll find out like the average GPA for each group, right? And if I find that, let's say, 60% of the party goers had a GPA below the mean for all of the UC San Diego students, right, or San Diego State University students, for all of the students, and that only 30% of the students who said they rarely attend parties had GPAs below, then it looks like partying causes lower GPAs. There's a difference of 30%, right? So in my party group, what I'm going to do is I'm going to take the average GPA for the school, and then I'm going to look at my party group, they're 60% below, and I'm going to look at my non-party group, and they're only 30% below, and it looks like then the amount of partying you do has a relation. This is a prospective observational study. I don't control who has the cause and who doesn't. I take people who will admit to having the cause and people who will say they don't have the cause and survey them. But I'm not assigning anybody to groups. I'm not randomly controlling that process. So that's what's different about a prospectional observational study. Okay? So then I'm going to conclude that attending weekend parties probably adversely affects a student's academic performance. The third is the retrospective observational study. In this one, we've got two groups, one where the phenomena of interest is universally present, the other in which it's universally absent. And we're going to look for a significant difference in the frequency of the causal agent in comparison groups is evidence of a causal linkage between the two. So let me just get to the example. Here's the question. Does partying on the weekends adversely affect academic performance? Okay, now it's the same question we had before, right? So now a different way that we can go about it is to grab students or look at students at San Diego State University and survey them about their weekend study habits. Okay? So I'm not dividing them into groups. I'm surveying everybody. And let's say that in that survey we find that 100 students on academic probation, and 60% of those said that they attended parties almost every weekend. By contrast, only 20% of the students not on academic probation identified themselves as having parties on most weekends. In this case, what we're doing is we're surveying them, and we're noticing that, hey, I've got these students who are on academic probation, and that usually means that you're not doing very well, right? Okay. Well, of those students who are not doing very well, well, what do you know? 60% of them attend parties. Now, this is retrospective, so this is looking back at their troubles, basically. By contrast, 20% of the 100 students not on academic probations identified themselves as attending parties. So I'm going to have my second group will be those who are not on academic probation. So I'm retrospectively from my survey taking the ones who have clear evidence of not performing well academically. And I'm noticing that there's something very interesting about that group. There's a high percentage of them who attend parties on the weekend. By contrast, of those, let's say, 100 students I found not on academic probation, only 20% of those said that they attended parties. It's clearly going to look like, in that case, that attending parties adversely affects the student's academic performance. But in the retrospective study, we're doing it differently than we did in the prospective study. In the prospective, remember, we divided up into two groups, one with and one without, and we looked for an increase in the presence of the effect in the group that had it. Here, we're doing our study, and we're noticing, oh, well, look, of my survey, I've got 100 students on academic probation, and then I've got 100 students on academic probation. 60% of those, which is a big number, right, go to parties. But by contrast then, right, of 100 students, if I randomly pull out 100 students who are not on academic probation, only 20% of those are on there. That's very different than, well, it's different than the method of assigning a group with and assigning a group without. What I'm doing is I'm going back, creating my survey, and now I'm retrospectively looking at that survey and saying, okay, well, let's take all the people on academic probation, right, because I've got this information, and take people not on academic probation. Let's do 100 of each, and then let's see. Hindsight, retrospective, observational study. Okay, I hope that that was helpful. Again, this is coming straight from your book, so if my explanation here isn't helpful, go back and forth between that and the book, and that should help you out. If you have any questions, let me know.